All right, guys, so we are moving on to 5.4, which is all about polygons. Okay, four-sided polygons specifically, four-sided polygons. The first thing we're going to do is we're going to define kind of what a polygon is. So it's a figure in a plane. So remember, a plane is like a piece of paper. And so I have some shapes down here to show you what I mean. So if we take a look at the first one, we see a triangle. I'll label this number 1. And this is a polygon. I understand that the specific name for it is a triangle, but it is a polygon. This second one right here is also a polygon, okay, 4, 5. So it looks like it has 5 sides. And then over here, our third shape is a polygon. It appears to be some kind of trapezoid. And then we have this fourth shape right here. Okay, so we're looking at this fourth shape, and it looks different than shapes 1, 2, and 3, right? It's like, well, wait a minute. It looks like it kind of goes in there like a Pac-Man mouth. That is still an example of a polygon. Okay, so this is still a polygon. Now down here, shape 5 is not a polygon. And the reason it's not a polygon is because of this right here. Okay, that is not a segment. It has to be made up of all segments. And this is obviously curved here. Sorry. So this is not a polygon. If you take a look at shape number 6, okay, shape number 6, it is also, well, the whole shape is not a polygon. I'm hesitating because the whole shape is not a polygon. It is 2 polygons put together. So if I asked you guys, is KPOM a polygon? You could say yes. If I asked you, is PRO a polygon? You would also say yes. If I asked you guys, is KPROM a polygon? The answer is yes. Okay, that is a polygon. But if you were to include that piece in the middle, then no. Okay, it's not a polygon. It has to consistently go around the outside. The same thing holds true for number 7. ABCDE is not a polygon. Okay, ABCDE is not a polygon. There's no point right here, so I can't even name that polygon. But as of right now, this one, we would say, no, it's not a polygon. And 8 is also not a polygon because, again, it's not consisting of segments that you see right there. Okay. The next thing we need to know is how to name a polygon. So let's just say, I'll draw some obscure kind of large shape here. So A. Okay. What you're going to do to name this polygon is you are going to pick a point to start at. I don't care what point it is. So I'm just going to be a rebel and I'm going to start. What do you guys think I'm going to start at? I'm a rebel, so I'm going to start at D. So I'm going to name this polygon D. And now I have a choice. I can either go clockwise or counterclockwise. I don't care which way you go. So D, I'm going to go this way. E, and I have to go in order. F, A, B, C. Okay, and then of course, because it's a polygon, we assume that we go back to the starting point of D. So this is this polygon. So if you were to, for example, have a problem and they said, looking at polygon, if you were looking at polygon A, D, F, B, okay, you would just assume it goes in this order. Now, I don't know exactly what it looks like. Okay, I like to draw it kind of obscure, but A to D to F to B, and then back around. That's how we name a polygon. So it goes in order starting with 1 point. Okay, a convex polygon is a polygon in which the interior angles, or these inside angles, all measure less than 180 degrees. So you can see that most of what we're going to be working with in here are going to be called convex polygons. Okay, This one over here is not a convex polygon. And that is because, again, looking at these interior angles, look at these. Oh boy, this angle right here at E appears to be like 200 degrees. And we're not working with, convex concave polygons that appear to be larger than 180 degrees. Okay, next is going to be diagonals. So we refer to a diagonal as any segment that connects two non-consecutive, that means one after the next, okay? So A and B are consecutive. A and C are non-consecutive. So if you were to join A with a point that is not right next to it, that creates a diagonal. So I can create AC as a diagonal, and I can also create BD as a diagonal. If you refer to this triangle, okay, I cannot create any diagonals because each of the vertices are right next to it. So again, you cannot connect a point with the points that are right next to it. Okay, so if you take a look at this next shape again, so A, B, C, D, E, F, G, H. If you take a look at A, if I were to draw all the diagonals from A, I would not be able to connect A to B or H. However, I could connect A to C, that counts as a diagonal. A to D, that's a diagonal. A to E, that's a diagonal. A to F. And A to G. Okay, so A has 1, 2, 3, 4, 5 diagonals coming from A. I could do the same thing for D if I wanted to. Okay, I cannot connect A to C, but I could connect D to B. I could connect D to A, D to H, D to G, and D to F. Okay, again, I cannot connect it to E that is not considered a diagonal. The last thing we want to take a look at is all of these definitions, okay? We're going to be going deeper into these. These are just the general definitions of what these polygons are being referred to as. So the first thing we're always going to be talking about in this is going to be the quadrilateral. And a quadrilateral is just a basic four-sided polygon. You can see the picture over to the side. They drew it purposely like this. It doesn't appear that any of the sides are congruent. It doesn't appear that any of the sides are parallel. That is your basic quadrilateral. The next shape that we are going to be discussing is going to be a parallelogram. And the definition of a parallelogram is that both pairs of opposite sides are parallel. Okay, parallelogram, easy to remember. Okay, next, let's do green. Our next shape is a rectangle. Now here's the deal. A rectangle is a parallelogram, so go back to the top. Look at this. You know what? I should do that in purple. A rectangle is a parallelogram, which is purple, right up top. So its opposite sides are parallel, in which at least one of the angles is right. Okay, so if you can prove to me that it has one right angle, hey guys, because it's parallel, you know that this also has to be right. Oh, because it's parallel, this also has to be right. So that's why as long as you can tell me that it has one right angle and it's a parallelogram, we consider that to be a rectangle. The next one is a rhombus. Let's do orange. So again, a rhombus is a parallelogram. So I'm going to come over here and mark it. Okay, so the opposite sides are parallel. It's a parallelogram in which at least two consecutive sides are congruent. Consecutive means two sides that are next to each other, like this. Those are two consecutive sides. If you can prove to me that these two consecutive sides are congruent, bam and bam, then we have ourselves a rhombus, because a rhombus is a square that we sat on. Okay, so as long as you can prove to me at least 2 consecutive sides are congruent. Next, we have a kite. What are we doing? Yellow? How's that? A kite is a quadrilateral. I did quadrilateral in blue. Okay, so it has to have 4 sides in which 2 disjoint pairs of consecutive sides are congruent. So this is what this means. I am going to I'll pick like a goldenrod color. That means that this side right here has to be congruent with this side right here. And then let's grab our other yellow. This side right here has to be congruent with this side right here. So it's a quadrilateral in which 2 disjoint consecutive sides are congruent. Next, we have our square. Guys, I'm running out of colors. Our square, okay? And our square is a parallelogram. So I'm going to come over here and mark it up. Okay? It is a parallelogram that is both a rectangle, which is green. Look at this. Rectangle. So that means you have to prove that it also has 1 right angle. Bam. And a rhombus. Let's get our orange. And a rhombus. And in order for it to be a rhombus, you have to prove to me that this side is congruent to this side. Okay, so that's why it ends up being all 4 sides are congruent, all 4 angles are right angles, and the opposite sides are parallel. Okay, then we have our trapezoid. Trapezoid is unlike any other. I already did blue, didn't I? Quadrilateral, I did blue. We'll do red. I'm not a red person. Okay, trapezoid, I'm talking to myself. A trapezoid is a quadrilateral, and quadrilateral is blue. Go back to red. With exactly 1 pair of parallel sides. The parallel sides are called the bases. So again, I'm going to highlight these in red. Okay, it has exactly 1 pair of parallel sides. So I'm going to do my fish gills there. And those sides are called the bases. Okay, and then of course we have our isosceles trapezoid, which again, I'm just going to color red because it's basically the same thing. So our isosceles trapezoid has 1 pair of parallel sides, and the non-parallel sides are congruent to each other. So this has a little bit more marking. Right here, right here, we still have our bases. But then we also have the non-parallel sides that are congruent to each other. So isosceles means 2 of these sides are congruent, and you can see 2 of those sides are congruent, just like an isosceles triangle. But, hey guys, if 2 sides are congruent, then 2 angles are congruent, okay? And in this case, it's the 2 bottom angles that are congruent to each other. Those are called our base angles. And the 2 top angles are congruent to each other, and those are also called the base angles. Those are the lower base and the upper base. They give them very specific names. I call them just the base angles because it could be upside down. But if you think about it, that has to be true because you have parallel lines right there. Okay, so that is our isosceles trapezoid. So please make sure you have this in your notes. You have this readily available. These are the definitions of our 4-sided quadrilaterals, our 4-sided polygons that you guys will need to know for section 5.4 and 5.5, because we're going to get into proving things are kites and rhombuses, rhombi, is it rhombi? And rectangles. So again, you need to have this written down, maybe make some flashcards for this to study the actual definitions of these quadrilaterals.